Quantum computers are a revolutionary leap forward in computational technology, utilizing the principles of quantum mechanics to perform calculations at speeds that even the world's most advanced supercomputers cannot match. To truly grasp how quantum computers work, let's use an analogy. Imagine you're playing a game of chess and trying to predict every possible move your opponent could make. A traditional computer will analyze these moves one by one, processing each possibility sequentially. While effective, this approach can be slow and computationally expensive. A quantum computer, however, would simulate all possible moves simultaneously, arriving at a solution in a fraction of the time. This ability to explore multiple possibilities at once is what makes quantum computing so powerful in fields that require vast amounts of data processing and optimization. Both utilize circuits, chips, and logic gates, and both follow algorithms to process information. However, the fundamental distinction lies in how they handle data. Classical computers rely on binary bits, either a 0 or a 1, to store and process information. In contrast, quantum computers use quantum bits or qubits, which can exist in a state of 0, 1, or both simultaneously, thanks to a property known as superposition. This capability allows quantum computers to conduct multiple calculations at once, vastly outperforming traditional computers in solving complex problems. To better understand superposition, let's consider a simple real-world example: flipping a coin. A standard coin has two states, heads or tails. When you flip it, it lands on one of these sides. But while the coin is spinning in the air, it is neither strictly heads nor tails. It exists in a state of both until it lands. Similarly, a qubit in superposition exists in multiple states at the same time. Now imagine having multiple qubits in a quantum computer. Since each qubit can exist in multiple states simultaneously, the system can process an enormous number of possibilities all at once, making quantum computers exponentially more powerful than their classical counterparts. But the magic of quantum computing doesn't stop at superposition. Another key principle is quantum entanglement, a phenomenon where qubits become linked, meaning that the state of one qubit directly influences the state of another, no matter how far apart they are. This interconnectedness allows quantum computers to perform computations in a highly efficient and coordinated. Entangled qubits enable significantly enhanced computational power, allowing quantum systems to solve problems that classical computers would take centuries to crack. Have you ever seen a quantum computer in person? If so, what was your first impression? If not, what do you think it looks like? Let us know in the comments. If you've ever seen a quantum computer, you'll notice that it looks nothing like the laptops or desktops we use daily. Instead of a sleek screen and keyboard, a quantum computer resembles an intricate chandelier, with layers of golden and silver structures, tubes and wires extending in all directions. The complexity of this setup comes from the need to maintain extremely low temperature, close to absolute zero, to stabilize the delicate quantum states necessary for computation. This highly controlled environment ensures that qubits remain in their quantum states long enough to perform meaningful calculations. Quantum computing has been in development for several decades, and today, major technology companies are actively advancing the field. Companies like Google, IBM, and Microsoft have already built operational quantum processors, using them for software development and testing new quantum algorithms. The biggest milestone in recent quantum computing history came in October 2019, when Google announced that it had achieved quantum supremacy. This meant that its Sycamore quantum processor had successfully completed a specific computation much faster than the world's most powerful classical supercomputer could. This demonstration confirmed that quantum computers could surpass classical systems in specialized tasks, igniting a global race among tech giants and researchers to push quantum technology even further. What are your thoughts on quantum supremacy? Do you think quantum computers will completely replace classical computers one day? Or will they only be useful for specific tasks? Share your opinions in the comments. As quantum computing continues to evolve, its potential applications are nothing short of revolutionary. In artificial intelligence and machine learning, quantum computers could analyze massive datasets at unprecedented speeds, significantly improving decision-making capabilities. Quantum computing is also expected to transform cybersecurity by introducing unbreakable encryption methods that protect data even while it's being processed. In the medical field, quantum simulations could lead to groundbreaking discoveries in drug research. accelerating the development of life-saving treatments. Additionally, quantum computing could enhance weather forecasting, optimize supply chains, and revolutionize battery technology for electric vehicles. Which industry do you think will benefit the most from quantum computing? Let us know your thoughts in the comments. While it may take years before quantum computers become a mainstream commercial tool, the advancements we've seen so far suggest that they will eventually become an integral part of our technological landscape. And who knows? With quantum computing's immense potential, perhaps one day it will not only solve the most complex scientific and mathematical problems, but also help you find your missing keys, predict the outcome of your next dinner date, and maybe even remind you why you fixed the date in the first place. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell so you never miss out on the latest tech news from Tech AR VR. Please like, share, and subscribe.